Now please write down, sir, HCF and its introduction. HCF and its introduction. HCF and its introduction. Listen carefully. HCF stands for highest common factor. HCF stands for highest common factor. Highest common factor. Now before we explain what is a highest common factor, let us underline the keyword what is a factor. Suppose take a natural number. If I divide this with any other natural number and the remainder is 0, then x is a factor of n. X is a factor of n if you divide n by x and the remainder is 0. If you divide a number by any other number and you are getting the remainder 0, then that number is a factor of n. For example, remainder 1, 12 divided by x is 0. 12 divided by x is 0. So the meaning is x is a factor of 12. X is a factor of 12. What are the factors of 12? Factors of 12 are 1 is a factor of 12, 2 is a factor of 12, 3 is a factor of 12, 4 is a factor of 12, 6 is a factor of 12, and 12 is also a factor of 12. So what are the values that will take x? 1 it will take, 2 it will take, 3 it will take, 4 it will take, 6 it will take, and 12 it will take. When you divide a number by any other number and the remainder is 0, then that denominator is said to be a factor of numerator. Then that denominator is said to be a factor of numerator. X is a factor of 12. And another point, sir, how did you get these 1, 2, 3, 4, 6, 12 directly? First take 12. Write it out into prime bases. 2 6 are 12. 2 3s are 6. So 12 is nothing but 2 square into 3 power 1. 2 square into 3 power 1. 2 square is 4. 4 into 3, 12. Write all the powers of 2. 2 power 0, 2 power 1, 2 power 2. Write all the powers of 3 starting from 0 to 1. 2 power 0, 2 power 1, 2 power 2, 3 power 0, 3 power 1. Now if you see here, 2 power 0 into 3 power 0, 1 ones are 1. 1 is a factor of 12. 2 power 0 into 3 power 1, 1 into 3, 3 is a factor of 12. 1 into 1, 1 into 2, 2 is a factor. 4 into 3, 12 is a factor. 4 into 1, 4 is a factor. 2 into 3, 6 is a factor. So 3 2s are totally 6 factors are there for 12. Anyway, in factors and multiples class, I am going to explain in detail how to write down all the factors of 12. How to write down all the factors of 12. Again, very, very important point. When you divide a number by any other number and the remainder is 0, then the denominator is said to be a factor of n. Then denominator is said to be a factor of n. Example, when 12 is divided by x, remainder is 0. So x is nothing but a factor of 12. X can be 1, x can be 2, x can be 3, x can be 4, x can be 6, x can be 12. Total 6 values are there for x. I hope the definition of factor is clear to you. Now, definition of factor is clear to you. Now, what do you mean by highest common factor? What is HCF? HCF is highest common factor. Highest common factor. Again, like we did it in LCM, HCF also we will do it in multiple methods. Method 1, generic method. Method 1, which is generic method. What is generic method? Generic method is a method which is there in our textbooks. N1 if I take 12, some natural number 12. N2 if I take 18, n1 is 12 and n2 is 18. Let us write down all the factors of 12. 1 is a factor of 12, 2 is a factor of 12, 3 is a factor of 12, 4 is a factor of 12, 6 is a factor of 12, 12 is a factor of 12. Similarly, what are all the factors for 18? 1 is a factor of 18, 2 is a factor of 18, 3 is a factor of 18, 6 is a factor of 18, 9 is a factor of 18, 18 is also a factor of 18. So first thing what we did is, we are moving from right to most, we took all the factors. Second step is, I will take common factors. I will take common factors. What are all common factors? Here 6 is common, here 3 is common, here 2 is common, here 1 is common. 1 is common, 2 is common, 3 is common, 6 is common. This step is also over. Then find out the highest. Highest among 1, 2, 3 and 6 is 6. So the HCF of 12 comma 18 is 6. HCF of 12 comma 18 is 6. I hope the idea is clear. Method 1. Method 1 is, write down all the factors of that number and take the highest common factor. Take the highest common factor. A factor is also called as a divisor. A factor is also called as divisor. Why? Because 25 when divided by 5, 5 5s are 25, remainder is 0. Now if you see here, 25 is the number which is getting divided, so it is called a dividend. Number which is dividing the dividend is called a divisor. So 5 is called the divisor. Here, how many times it is going? 5 times it is going, so it is a quotient and it is a remainder. And it is a remainder. Because 12 is perfectly divisible by 6 or 12 or 4 or 3 or 2 or 1. Any factor is also called the divisor. Common remains the common. Highest can also be said in synonym as greatest common divisor. So another synonym for HCF is GCD. GCD or HCF, both are synonyms to each other. HCF is highest common factor. HCF is highest common factor. It is also called as greatest common divisor. It is also called as greatest common divisor. I am not interested in this method 1. Method 1 is for us to understand each and every word in highest common factor. How to take factor, how to take common factor, how to take highest among the given factor. How to take the highest among the given factor. Definition of HCF and how to find out the HCF of two given numbers. Why HCF is also called greatest common divisor. Now, some important key points. Some important key points. Important key points. First one, HCF of 1 with any natural number. HCF of 1 with any natural number, it is always 1. HCF of 1 with any natural number, any natural numbers is also 1. Example, HCF of 1 comma 23, 1. HCF of 1 comma 24 comma 28, it is also 1. HCF of 1 with any natural number, it is 1. HCF of 1 with any natural number, it is 1. First point. Second point, HCF of co-prime numbers. Write down in the same order, sir. HCF of co-prime numbers, it is always 1. HCF of co-prime numbers is always 1. What do you mean by co-prime numbers? Only one factor common. Only one factor common, that is 1. If there is only one factor common and that is 1, then HCF of co-prime numbers is always 1. HCF of 1 with any natural number is 1. HCF of any co-prime numbers is always 1. For example, HCF of 5 comma 7 is 1. 5 comma 7 is 1. HCF of 12 comma 25 is 1. 12 comma 25 is 1. HCF of 17 comma 18 is 1. HCF of 17 comma 18 is 1. Now if you see here, why I took these three examples. 5 is a prime number, 7 is a prime number. For a doublet to become a co-prime numbers, it is not mandatory that both the numbers should be prime numbers. Both are prime numbers. Both are composite numbers. One is a prime number, another is a composite number. Second important key point, HCF of any co-prime numbers is 1. HCF of any co-prime numbers is 1. HCF of 1 with any natural number is 1. HCF of 1 with any natural number is 1. All these key points I am going to solve it in problems. Very, very good questions you are going to solve it today, sir. HCF of co-prime numbers is always 1. HCF of co-prime numbers is always 1. Third one, third key point. HCF of any two consecutive HCF of any two consecutive natural numbers, it is always 1. HCF of any two consecutive natural numbers, HCF is always 1. For example, HCF of 31 comma 32. 31 and 32 are consecutive natural numbers. HCF is 1. HCF of 91 comma 99 comma 100. HCF of 91 comma 99 comma 100. 99 and 100. 99 and 100, they are two consecutive natural numbers. Consecutive natural numbers, HCF is 1. 1 with any natural number, again the answer is 1. HCF of any two consecutive natural numbers, HCF is 1. HCF of any two consecutive natural numbers, HCF is 1. Fourth point, HCF of any two consecutive even numbers. HCF of any two consecutive even numbers. HCF of any two consecutive even numbers is 2. You take any two consecutive even numbers, HCF will always be 2. Why it is 2? Why above should be 1? Everything we will discuss once I discuss congruent modulo theorem. HCF of 4 comma 6. 4 comma 6 are two consecutive even numbers, so it is 2. HCF of 24 comma 26. HCF of 24 and 26 is again 2. HCF of any two consecutive even numbers. In any two consecutive even numbers, HCF it is 2. HCF it is 2. HCF of any two consecutive natural numbers. HCF of any two consecutive natural numbers, it is 1. It is two consecutive natural numbers. It is two consecutive even numbers. It is two, any two consecutive even numbers is 2. Suppose, next one. I hope it is clear. Some important key points. Any two consecutive natural numbers is 1. Any two consecutive even numbers is 2. Suppose if it is HCF of 15 comma 20. HCF of 18 comma 27 comma 36. HCF of 36 comma 48. HCF of 36 comma 48. HCF of 36 comma 48. What if the numbers are not co-prime to each other? What if the numbers are not co-prime to each other? What if the numbers are not co-prime to each other? How to find the HCF of the given numbers? What if the numbers are not co-prime to each other? Make them co-prime. HCF of 15 is 5 into 3. 20 is 5 into 4. Common number is 5. Take 5 out. 5 of HCF of 3 comma 4. HCF of co-primes is always 1. So 5 ones are 5. 5 ones are 5. Again, HCF of 18, 26 and 45 let us take. HCF of 18, 26 and 45, which is 9 2s are, next is 9 3s are, next is 9 5s are. 9 is common, taken out. HCF of 2, 3 and 5. 2, 3 and 5 are co-primes to each other. Co-prime numbers HCF is 1. 9 ones are 9. 9 ones are 9. I hope it is clear. Same like what we did it in LCM. First we will understand the definition of HCF. Then we will solve some very high quality problems. HCF of 36 comma 48. 12 into 3 comma 12 into 4. Take the factor common out. 12 is taken out. HCF of 3 comma 4. 3 comma 4 are co-primes. So 12 ones are 12. 12 ones are 12. If the numbers are not co-prime to each other, make them co-prime to each other. 5 3s are, 5 4s are. Take the factor common out. Take the factor common out. Take the factor common out. 9. HCF of 2 3 5 is 1. Take the factor common out. Take the factor common out. Now, I hope it is clear, right? What if the numbers are not co-prime to each other? Now listen carefully to every statement which I am saying after this slide. Side heading write down. Congruence. Congruence. Modulo theorem. Congruence. Modulo theorem. Congruence modulo theorem. Now see here. What is congruence modulo theorem? First I will take an example, then I will write the point. Suppose there are two natural numbers 5 and 7. Hypothetically, let us assume that there are two numbers 5 and 7. 5 and 7 are co-prime to each other. Co-prime numbers HCF is 1. First point. HCF of 5 and 7 is 1. Suppose I add these two numbers. 5 plus 7 is 12. If you observe, if 5 and 7 are co-prime to each other and their HCF is 1, 5 with 12 is also giving you HCF 1. Am I right? 5 with 12 is also giving you HCF 1. 7 with 12 also is giving you. 7 with 12 is also giving you HCF 1. Because if 5 and 7 are co-prime to each other, 5 and 12 are also co-prime to each other because there is only one factor common, that is 1. 7 and 12 also are co-prime to each other because there is only one factor common, that is 1. Now, let me do the subtraction. 7 minus 5 is 2. Now, if you observe, 2 and 5 are also co-prime to each other. So, 2 comma 5 is 1. Again, if I do 7 with 2, 2 comma 7 is also 1. 2 comma 7 is also 1. That means, what did you realize? If I take two numbers A and B, if both are congruent under some property, here the example is both are congruent under co-primes. if HCF of A comma B, if I got a value, it is also equivalent to HCF of A comma A plus B. Am I right? It is also equivalent to HCF of B comma A plus B. Am I right? It is also equivalent to HCF of A comma B minus A. Am I right? It is also equivalent to HCF of B comma B minus A. Am I right? If two numbers are congruent under some property, if two numbers are congruent under some property, even if you do modulo addition, the HCF value will not change. Even if you do modulo subtraction and do HCF with an individual number, HCF does not change. But if I do this both, which is A plus B and B minus A, what is HCF of 12 and 2? 12 and 2 HCF is 2. But according to the question, 5 comma 7 has to be 1. It is may or may not be equivalent to, may or may not be equivalent to A plus B and B minus A HCF. A plus B comma B minus A HCF. Listen carefully to my statement. Take two natural numbers A and B. A and B. A with the addition of two numbers. B with the addition of two numbers. HCF does not change. HCF does not change if you do HCF with sum of two numbers. HCF does not change if you do with a number with subtraction of two numbers. Individual number with the addition of two numbers, individual number with the subtraction of two numbers. HCF does not change. HCF does not change if I do individual number with the addition of two numbers and the subtraction of two numbers. I hope it is clear. But addition and subtraction, if you do it, it may or may not be same. Sometimes yes and sometimes no. Sometimes yes and sometimes no. I hope this point is extremely clear to you. See the heading, congruence modulo theorem. What do you mean by congruence modulo theorem? If two numbers are congruent under some property, modulo addition with individual numbers, modulo subtraction with individual numbers, congruency does not changes. Congruency does not changes. I will write neatly in the next slide. If A and B are congruent under some property, if A and B are congruent under some property, HCF of A comma B, it is also equivalent to HCF of A comma A plus B. It is also equivalent to HCF of B comma A plus B. It is also equivalent to HCF of A comma B minus A. It is also equivalent to B comma B minus A. May or may not be equivalent to, sometimes yes and sometimes no. So we will not write that. May or may not be equal to HCF of B plus A comma B minus A. Please make a note of this extremely important key point. Very, very important key point. If two numbers are congruent under some property, individual number with the addition of numbers, individual number with the subtraction of numbers, HCF will not change. I hope it is clear, right? If A and B are congruent under some property, let us take an example. Example, HCF of 15 comma 20. HCF of 15 comma 20. 15 and 20 HCF is 5. 15 and 20 HCF is 5. it is also equivalent to HCF of 15 plus 20 is 35. 1535 HCF is 1. HCF of 15 comma 20 minus 15 is 5, which is also 1. Which is also 1. In this case, Naveen, congruency means, in the previous example, congruency could be anything where these two numbers satisfy some property. In the previous example, two numbers are co-prime numbers. So A and B are congruent under co-prime set. In the second example which I wrote, 15 and 20 are congruent under a set which is multiple of 5. Multiple of 5. So the congruency means they both will behave similarly under some property. I hope it is clear. A and B are congruent under some property. HCF of A comma B is A comma A plus B, B comma A plus B, A comma B minus A, B comma B minus A. Idea clear, right? Next important point. After this, we will solve a problem. We will solve a problem. If two numbers are congruent under a property, addition of two numbers with the individual numbers, subtraction of two numbers with the individual numbers, HCF does not change. HCF does not change. HCF does not change. I hope the idea is clear. Everybody kindly reply it in the live chat if it is clear to you. If it is clear to you, kindly reply it in the live chat. Right, everybody says clear. One more point. Right, largest factor method. Largest factor method. Largest factor method. Another way to do HCF, for finding HCF. Largest method, factor method for finding HCF. Largest factor method for finding HCF. Suppose HCF of 9 comma 12 is there. HCF of 9 comma 12 is there. Now 9 comma 12. How generally in our school days we will do? 9 ones are 9. Remainder is 3. Am I right? So we will check whether these 3 is dividing these 9. 3 3s are 9, remainder 0. So think logically, if this is B and it is A, what am I getting? B minus A. If B minus A, 3 3s are 9, remainder 0. So what you do is, method 1, take the factor of difference between numbers. Take the factor of difference between two numbers. Difference between two numbers. What is 12 minus 9? 3. So factor of 3. If I take factors of 3, 1 is a factor of 3. 3 is a factor of 3. Check for the largest number which will divide every number. 3 3s are 9. 3 4s are 12. Write the largest one. Write the largest one. Right? Take the difference between two numbers. 12 minus 9 is 3. Factor of 3 is 1 and 3. Check whether what is the largest number that will divide this number. 1 will divide 9, 1 will divide 12. 3 will divide 9, 3 will divide 12. But the largest number is 3. But the largest number is 3. I hope you got the idea. Right. Few more examples. Largest factor method for finding HCF. Largest factor method for finding HCF. HCF of 15 comma 25. HCF of 15 comma 25. Take the difference between the two numbers. 25 minus 15 is 10. What are all the factors of 10? 1 is a factor of 10. 2 is a factor of 10, 5 is a factor of 10, 10 is also a factor of 10. 10 is also a factor of 10. I hope it is clear. Now, if you see here, 15 is an odd number. 15 is an odd number. 25 is also an odd number. HCF of odd numbers. HCF of odd numbers is always an odd number. HCF of odd numbers is always an odd number. HCF of odd numbers is always an odd number. 10 is out, 2 is out. Check with 5. Is 15 divisible by 5? Yes. Is 25 divisible by 5? Yes. 1 also will divide 15, 1 also will divide 25. Largest number which we have to take. Largest number will be the HCF. So answer for this question is 5. Answer for this question is 5. So if numbers are there, take the difference between the two numbers. Take the difference between the two numbers. I hope it is clear, right? Take the difference between the two numbers. What if 3 numbers are there, 4 numbers are there? Everything we will discuss once we understand this concept. So please write down this key point. HCF of A comma B. If I want to find out the HCF of A comma B, answer is an element. Answer is an element in the set factor of B minus A. If B is greater than A. HCF of any two numbers, answer is nothing but element in the set factor of their difference. Element in the set factor of their difference. Another important concept. Element in the set factor of their difference. Suppose if 3 numbers are there. Suppose if it is 24, 36 and 18 is there. 24, 36. 24, 36 and 18. If 3 numbers are there, what you do is, what is the lowest number? 18. What is the highest number? 36. Lowest number is 18. Highest number is 36. Take their difference. Factor of 36 minus 18 is 18. What are the factors of 18? 1, 2, 3. 6, 9, 18. 1, 2, 3, 6, 9, 18. Check with the largest. Is 18 dividing every number? 18 ones are 18, 18 twos are 36. It is not dividing. Is 9 dividing every number? 9 twos are 18, 9 fours are 36. Is 6 dividing every number? 6 threes are 18, 6 six are 36, 6 fours are 24. Answer for this question is 6. Answer for this question is 6. If more than 2 numbers are there, take the lowest number present in the set. Take the highest numbers present in the set. Take the difference between the 2 numbers. Take the difference between the 2 numbers. Take the lowest number and take the highest number. Determine the factors for the difference between the lowest number and the highest number. Lowest number and the highest number. I hope it is clear. I hope it is clear. Now we will solve some very good problems based upon whatever we have discussed. Rashid, I already told you HCF of 2 consecutive even numbers is 2. If it is any other even number, if it is suppose HCF of 20, 24, it is there. 2 even numbers. Take the common factor out beta. 4 into 5 and 4 into 6. 4 is taken out. HCF of 5, 6. So, co-primes HCF is 1. 4 ones are 4. This is how you do HCF of even numbers. HCF of even numbers. 2 important key points which I am repeating is factor of the difference method, factor of the difference method, point 1. Point 2, HCF of A comma B is also equivalent to HCF of A comma A plus B. It is also equivalent to HCF of A comma B minus A if B is greater than A. Third key point, HCF of two consecutive even numbers. Two consecutive even numbers is 2. HCF of 1 with any natural number. 1 with any natural number is 1. HCF of two consecutive natural numbers is 1. Please write down these 3 important key points. HCF of two consecutive even numbers is 2. HCF of 1 with any natural number is 1. HCF of two consecutive natural numbers is 1. Shivashakti, right? Shivashakti, which can you please take an example? Narendra, HCF of two consecutive odd numbers. Two consecutive odd numbers is always 1. We have already written HCF of 5 comma 7 1. HCF of 11 comma 13 1. 11 comma 13 1. 11 comma 13 1. I hope it is clear till here.